Among 3D printing processes out there, all of them, stereolithography really excels in small feature resolution and tight tolerances and smooth surface finishes.
Stereolithography was very early on adopted by the medical industry. So we do a wide range of medical devices, medical instruments.
Probably the largest benefit of SLS specifically is the fact that this is an actual thermoplastic material, so it exhibits much better mechanical properties. A large percentage of our parts are for customers that are doing injection molding, but they realize they can take advantage of the reduction of components with snap fits, living hinges.
SLS, you see more end-use functional prototypes where maybe surface quality isn't as much of a desire for the customer when they want to do good form and fit functional testing.
A good use of DMLS technology is reduction of components. So any way that you can reduce the assembly time, reduce the part count, is going to in turn reduce the cost of the process. Anything that goes up in the air adds weight, and weight adds fuel and cost. So reduction of components is very key in the aerospace industry for that reason.
The density of the DMLS parts is going to be very comparable to a billet or machined metal part. Strength properties and all the different specifications are also going to be very close to what you would see out of a machined or even die-cast part.